Hey everyone, my name is Anvita Bansal and we are back with another lecture based on linked list. Give me a moment so that I can check if we are live. Yes, we are. Okay, so starting off with the problem for today, which is pairwise swap of a linked list. Okay, let me show you the problem statement. So this is the one, pairwise swap of a linked list. So what is given to you? You are given a linked list in this question. I am assuming you have already gone through the question. Your task is to swap them pairwise, okay, which I will explain obviously clearly. One thing that you need to note here is that you need to swap the nodes, not just the data. Now I'll tell you what we need to do. I'll take this example and then I'll take another one. Fine. For example, this is your test case. Now, if I want to swap it pairwise, by this, what do I mean? First, you need to understand the question, correct? Okay. So, if I swap them pairwise, by this I mean I should be swapping two nodes at a time, not at a time. Basically, you have to swap two nodes together in the linked list. So, when I swap them, my resultant would be like this. 1, swap it with 2. What I'm going to get? 2, then 1. Come to the next pair of nodes. It's 2, 4. When you swap them with each other, 4 will be the next pointer of 1 and 4's next will be 2, right? Focus on the 2 nodes every time. Then next 2 nodes in this pair is 5, 6. When I swap them, the next will be 6 and 6 next will be 5, right? Now the next pair is 7, 8. So 8 will come before 7 and 7's next finally will be null. Fine. In case you are wondering what if we have odd number of nodes in this. Hi guys, I can see you all live. Fine. So in case if you are wondering what if I have odd number of nodes, in that case also let's have a look at the problem. For example, I have 1, 2, 3, 4, 5. Okay. So the resultant of this linked list by swapping two nodes at a time, you guys are not able to see my screen. Let me check. Okay, wait. I'll just have a look why it's not. It should be visible. Can you guys tell me if my screen is visible? I think it is. Yeah. So the resultant for this particular test case would be, let's swap the first two pairs. It is 2 pointing to 1. Okay. Then next pair is 3, 4. Swap them. You'll get 4 pointing to 3. Next pair is 5 and null. So you must be wondering, null should come before 5. No, that's not going to happen. If you are left with only one node in the end, swapping, you do not have any other node to swap it with. So you will keep it as it is and 5's next will be null. Let's have a look if our question has a test case like this. So 1, 2, 3, 4, 5, 6, 7. So as you can see, we have odd number of nodes here. So all the pairs were swapped, 3 with 1, 3, 1, then 7, 4, 7, 4, then 10, 9, 10, 9, and 1 does not have any other node to swap. So it will be as it is. I hope the question is very much clear to you guys. Now, how can we solve it? I'll start with one approach, which a lot of people might come up and end up getting the wrong result. Why? Because what you guys sometimes, not all obviously, but sometimes it might happen that you go ahead by just swapping the data of the node. But the point here is that if this is a node of, for example, this is node whose data is 1, this node's next is what? Another node whose data is 2. What you guys might do, that within the same node, you just change the data of that node. So this will become 2 and this will become 1, but the nodes remain the same. For example, if the address of this node is X and the address of this node is Y, then address of the nodes remains same and you just go ahead and change the data. So that should not be the case. This is what question has explicitly mentioned, that you have to change the entire node. That means this Y node should come here along with its data what it originally had. So it had 2 originally, so this should come here, and now 2's next should be pointing to this node whose address is X. I hope you got the point here. Okay, now let's move on to the approach. How are we going to do this? Focus on just swapping 2 nodes right now. If you have something like this, fine. So focus on just swapping 2 nodes right now. 1, 2, 3, 4, 5, 6. For example, this is your test case. Tell me, if your question comes down to only swap 2 nodes of a linked list, how would you do? For example, if your linked list is just 1, 2, I am asking you to just swap them. What will you do now? This is your head node. Okay, so let's take one node here, node temp. Okay, and let us point this node to which node? Tell me. You will make it point to head.next, let's say, equal head.next. Now I'm just asking you to swap just 2 nodes, assuming that okay, it is just a linked list of 2 nodes. Now next thing, what would you do? If you just want to swap it, this temp is now pointing here. You will make temp point to 1, but one thing you have to ensure that once next after swapping, it will look like this. Okay, so we should have the address. Right now it is null, but for example, if it was not null and it was some other node whose data is 3, so in order to have the address of that node so that we don't miss on it, because we after swapping, one should be pointing to some other node which is right next to temp node, right? So in order to have the address of that node, I will take another pointer, another node, let's say node aux, which will be pointing to temp's next. This is your temp, and temp's next, if it is null, so auxiliary will be null. If it is some other node with a data, for example 3, it will be pointing to node with value 3, right? So I hope you understood why we are taking another pointer, so that we have the address of next node, because after swapping, how do we know that after swapping we should know what 1 is pointing to. So in order to have that address, I am taking another pointer, auxiliary. Let me just not make it null, let me make it another node whose value is 3, so that you will understand better. Okay, this is your, and then it is null and you don't have to worry. For example, this is your test case. So it should be, the resultant should be 2, 1 and 3. Got it? Fine. Now what? Now point the node, how it would look like after swapping. Now I want temp to point to your head node. So temp next should be pointing to which node? Head node. What is the reason? Because I want to swap it. So this link has been destroyed and 2 is pointing to 1. And since 2 is pointing to 1, this node has been destroyed. We already have 3 and aux is pointing to 3. Right? Now what is your link looking like? Your link is like this. 2 is pointing to 1 right now. Fine. And this link is destroyed because it's a singly linked list. Now you have 3, which is accessible by your aux node. Okay, but you have to shape this linked list so that it looks like this. That means this is how the nodes should be. 2 is pointing to 1, that is fine, but 1's next should be pointing to the aux node, right? So for that case, what would you do? 1 is your head node, right? So basically this head.next should be pointing to aux. Fine. Head.next should be pointing to aux, right? So this thing you have done clearly when it was a linked list of size 3. But what if this size increases? Are you going to do it always like this? So what we have come up, the solution that we have come up with is that do your task for 2 nodes and ask recursion to solve for the rest of the nodes in pairs. Your entire task will be that you do this thing. When you were pointing to aux, you knew that aux was the only node that was present in your linked list because it was of size 3. But what if your size increases, right? Which it will, obviously. So what our intent here is that we will ask recursion to do that task, and we will assume that recursion has given us the answer. So the swapped nodes, for example, 4 will be pointing to 3 in case of already swapping if it is done. So my head.next will not be pointing to aux, but it will be pointing to the node that recursion will return me. So for example, if the function name is func, so I will make a call to func. This is where I'm making a recursive call. Func, and which node will I pass now? My func will be passing your auxiliary node, because the new head for this recursion would be this auxiliary node, for which I will be again calling this function, and it will be doing the task of swapping them. And here I passed aux. Now tell me, what should my recursion return me? If I want this node, the swapped node, when 1 is here, 1 should be pointing to the swapped node of this pair. So basically 1 should be pointing to 4. So tell me, in every recursion call, the node which is becoming the new head of the swapped pair, how am I addressing that node? So you will clearly see that your temp is always pointing to the node, right, which becomes the new head of your swapped linked list. So your recursion should be returning you temp, return temp, right? So this is your entire pseudocode. Now if I talk about what should be the base case condition, so base case condition will be, you will keep making calls to recursion until your node which you are passing, until your head node itself, right, it becomes null, or head.next is null. Very clearly I'll just write the base case here. And once, this is the entire code actually, I'll write this code in the compiler, we will compile it, and then I will come back and show you how recursion is taking place by doing again one dry run on an example. Because every time your func, this is your func which is taking node head, right, it is taking some node head. So my base case is on this head. Then every time I'm passing a new head, because see, this is being monitored, this is being taken care by this aux node. So whenever I am checking for the new head, if either my head itself is null, or if my head.next is null, that would be the case when I'm dealing with the linked list of odd size. That means if only one node is left in the end, you don't need to do anything, do any swapping or make another call. Return your head node, whichever it is, return head. If it is null, you will return null. If it is some legit non-null node, you will return that, right? So let's first code it, then I will come back and show you how recursion calls are being made on an example. Fine. So far, if you guys have any doubts, you can ask me. I'm writing the code here. If, give me a second. The exact thing that I wrote in the pseudocode, right, which is actually the entire code, I'm writing it here. If head is null or head.next is null, return your head node itself. Fine. And this will be the function that I'll be making repetitive calls for recursion. Okay. The next thing is I am taking an extra node temp, which is actually pointing to head.next. Fine. Next node I am taking to store the address of the third node. You have two pairs of node. The second node is referenced by temp. Now the third node, to store its address, I am taking new node which is aux, which is pointing to temp.next. Fine. Now temp.next. Now this is where I am doing the swapping thing. Now here I am actually swapping. Temp.next should be pointing to your head node, right? Now a new link has been formed for the swapped pair. Now your head.next should be pointing to the next swapped pair's head, right? So for that, I will ask my recursion to do the remaining task. So make a call to your pairwise swap function, in which the new head will be what? You have done the swapping for the first two nodes. Now the third node should be passed to pairwise swap. So that third node we have referenced using your aux node. So pass it, fine. And then you return. Which node do you return? I already told you why we are returning temp node, because temp will eventually become the node, the head of the swapped pair of nodes, right? Let's check. Let's submit it. So that is all, and we are done with the solution part. Coming on its time complexity, and then again I'll do the dry run. I'll just take the code, complete code. See, it was this simple. Why we use recursion here? First, the readability of code improves a lot using recursion. Second, there is no difference of time complexity. I'll show you, it's just on. We are just asking recursion to swap for us, and every time at max we are going at any node for once only. It's not taking more time than that. This is the reason your time complexity will be big of n. And obviously, since we are using recursion, so in memory stack some space will be used, which is not even on, less than that. At most, how many nodes will be stored? That is why your space complexity will be big of 1. So there is no difference in the time complexity if you do it iteratively or recursively. In iterative, obviously this is the best approach. In iterative, you might end up swapping the data and not the nodes. That is why go ahead with this one. And yeah, so now I'll show you the dry run. Let me take this test case. One pointing to 2. Fine. For example, this is your test case. Now start here. Right now your head is pointing at this node. Fine. Okay. If head is null, is your head null? No. Is your head dot next null? No. So you go to this line of code. Temp, you are making point to head dot next. This is your head dot next. So this is your temp pointer as of now. Auxiliary is pointing to temp dot next. So this is where your auxiliary is pointing. Okay. Now you're swapping temp dot next is head. So this link is removed. This link is removed. I'll write it here. So the 2 is going to point to 1 and head dot next. So basically what is happening, 2 has pointed to 1 in this line, and head dot next, this was your, still this is your head and still this is your temp. Okay, and aux is still at 3. We have stored 3 there. Now what? Head dot next, this was your head. Head dot next is making a call to your function pairwise. So this is the recursion call which is making a call to the function with head node is auxiliary. Auxiliary is what your aux is what you're passing. So your node that has been passed is the one with data 3. Now pairwise function, when I called it, I will again execute these lines of code. Now tell me for this, what is the head now? Right now the head is pointing to this 3. This is your new head now, right? I'll just erase it. Now this is your new head. Fine. Repeat the same steps. Node temp is pointing to head dot next. This is your temp right now. And your aux is pointing to temp dot next. This is your aux present. In this line, temp dot next is pointing to 4. So within this function, now what I have done is I have made 4 point to 3. Correct? Okay. 4 is pointed to 3. And what in the next line, what you are doing? In the next line, head, what is your head? since you know that 3 head was pointing to 3, so head is still at 3 and 4 is your temp, aux is 5, so head dot next is making a call to now pairwise. Again this function I am asking it to do the same thing. For this time your aux is what, 5, so the new head this time is 5, so pairwise is going to execute the same thing. Now check the first condition for this function. Head is null, no, head is not null, head dot next is null, so 5 is your new head. Now I'll just remove it. Now this is not your head, this is not your temp, your new head is now 5. Okay, so in this line head dot next is definitely null, this is null now, so you return head. Now when you return head, so this head has been returned. Now we are doing the steps of returning. You returned what, 5 was your head, right? So this 5 got returned to this function which made a call to it. Now this function will return its answer to the function which made a call to pairwise 5. So pairwise 5 was called by this function in which we were executing this link. So this result, when it is returned to this function, it was expecting some result to which 3 will point to. So what result it returned? 5. So this link has been created here. Now what is, for recursion, what are we returning? We are returning temp node. So this function returned its node which was 5. Now this pairwise 3, it will return its answer which is pointing to 4 because temp node is 4. So this temp is returned to this function, that was your pairwise. Pairwise, what was your initial head? It was 1, right? So this function will get its answer from pairwise 3 which is your node 4. So when I return my answer to this, what will come along? 4 is already pointing to 3, 3 is already pointing to 5, and I am returning 4 as my answer. So this pairwise 1 was expecting some node to which 1 will link to, right? And what is that some node? That node is the one having value 4, and other rest of the nodes come along. So 2's next is 1 and 1's next is 4. So do you see that how recursion has helped us swap all the nodes and we have gotten the answer? And finally you return temp, which is which node? Temp pairwise 1. When we were at pairwise, this is how recursion has returned its answer. Now this was the first recursion call made. The temp node for this recursion call is 2. So the address of this node will be returned which is acting as your new head. And that's how you have solved the problem. So the resultant expected was swapping these two will become 2 1, swapping these two will become 4 3, and 5 does not have anything to swap with, so 5 will stay as it is, and this is null. We got our answer 2 1 4 3 5, right? So you have seen that how using recursion also we were at max accessing every node only once. So time complexity is big O of n, no space. Big O of 1 is the space complexity. So any doubts so far? Got it? I can see people commenting that they got it. Okay, so okay guys, if you do not have any more doubts, I will wrap this up. If you want to ask something, you can ask me. Okay, so let's have a look here. I think you guys already understood it. Fine then. I think that was all. Then see you all in the next lecture. Till then, take care and keep coding. Bye bye.